Hello everyone. In this lecture of the Essential Calculus Problem series, I will solve this integral. Integral of square root of sine x multiplied by cosine cube x dx. Let me write the integral again here. Square root of sine x multiplied by cosine cube x dx. If we have an integral of a function u, and if we have its derivative multiplied by dx, we can use substitution, and u may be as just u square u cube, or this may be u prime dx divided by u, or u square, or cube root of u square. It's not important. What is important here is that if we have a function of u and its derivative multiplied by dx, we can use here substitution. But in this function given us, we have sine x and cosine cube x. If in order to use substitution here, we need a multiplication of cosine x dx. Square root of sine x. In order to do that, I will split cosine cube x as cosine square of x times cosine x dx. The derivative of sine x is cosine x. So if our function is can be written by using sine x, since we have here the derivative of sine x is cosine x, we have here cosine x times dx. So if we can write this part using just sine x, then the integral can be solved. And we know that cosine square of x is equal to 1 minus sine square of x. So I can rewrite this part as 1 minus sine square of x. Then the integral becomes square root of sine x times 1 minus sine square of x times cosine x dx. Now we have an integral of a function of sine x, and the derivative of sine x is multiplied by dx. Then we can now use substitution here. Okay, the function, let me write sine x is equal to u, then cosine x dx will be equal to du. Now we rewrite sine x as u here, and we rewrite cosine x dx as du. Now our integral is square root of u, and okay, that's square root of u times 1 minus u square du. In order to solve this problem here, I need to write square root of u as u to the power of 1 over 2. U to the power of 1 over 2. Now we will multiply it by u to the power of 1 to u to the power of 1 over 2 multiplied by 1 is u to the power of 1 over 2, multiplied by u square is minus u to the power of 1 over 2 plus 2, 5 over 2, u to the power of 5 over 2 du. And now remember, if we have a function x to the n, to integrate it, we add 1 to the exponent and divide by the new exponent. We have here, let me write it, u to the power of 1 over 2 du minus integral of u to the power of 5 over 2 du. Now to integrate it, we will add 1 to the exponent, u 1 over 2 plus 1, and divide by the new exponent, and minus u to the power of 5 over 2. We will add 1 and divide by the new exponent. 1 over 2 plus 1 is equal to 3 over 2. Then u to the power of 3 over 2 divided by 3 over 2 minus u to the power of 5 over 2 plus 1, 7 over 2. 7 over 2 divided by 7 over 2. Now we will, this will be equal to 2 over 3 square root of u cube. U was sine x, sine cube x, minus 2 over 7 times u square root of sine to the power of 7x. And since this was an indefinite integral, we will add a constant c here, and the answer is this. And in the next video I will solve this problem, cosine to the power of n x dx, and here the exponent will be an odd number. Okay, see you in the next problem.